I'd like to introduce to you the connection between displacement, velocity, and acceleration. So first of all, I want to point out that displacement has a lot of synonyms that can be interchangeably used in different situations. Sometimes people will say displacement, sometimes people might say distance, they might say position, they could even say height. Basically, it's talking about where something is in space at any particular time. Velocity is how fast something is going, and it has direction with it. So whether it's positive or negative has meaning and depends on the context of the problem. And acceleration is the rate of change of the rate of change, aka it's how fast the velocity is changing over time. Now, thinking back, remember that the derivative is the instantaneous rate of change. So it makes sense that if you take the derivative of displacement, you get the velocity, because displacement is where something is, and the rate of change of that would be where something is over a certain period of time. And that is velocity, how fast something is moving. Okay. Similarly, the derivative of velocity, well, that's asking for the rate of change, or the instantaneous rate of change of the speed over time. So it's the rate of change of the rate of change. And that gives you acceleration. Now, speaking of units, displacement is usually going to be in inches, feet, meters, something like that. Therefore, velocity is going to be that same unit of distance divided by whatever unit of time. So distance over time is our units here. Now for acceleration, it's distance over time divided by time, which is the same as distance over time squared, whatever those units may be. Now, let's look at this in context. So let's say you're throwing a tennis ball up in the air, and the height of the ball can be modeled by the function h of t is equal to 20t minus 16t squared. Let's say we have t is in seconds, and h of t is in feet. Now let's say we want to know how fast the ball is moving at a time of 1 second. Now in displacement, velocity, and acceleration problems, you're going to need to look for keywords. And in this problem, the keyword is fast, because that is telling us what we need to find. Fast relates to velocity, so we need to find the velocity function. To find the velocity function, I need to take the derivative of the original displacement, or in this case, height function. Now, this is a nice one because it's just it would be a power rule. So my velocity function, which I can label v of t, I could also call it h prime of t, because it's the derivative of the height equation, would be 20 minus 32t. So now that I have the velocity function, if I want to know how fast it's moving, I want the velocity at a time of 1 second. So that means that I want v of 1, which would be 20 minus 32 times 1, which is 20 minus 32, or negative 12 feet per second. Again, units for velocity are the distance or displacement units over time. And this negative has a really big meaning in this problem. Okay? Okay, so since we're talking about up and down motion, and the ball is being thrown up in the air, this negative means that it's going down at a rate of 12 feet per second. Notice I didn't say that it's going down at a rate of negative 12 feet per second, because I can either say this is the rate of change, or I can say that it's going down and the rate is 12 feet per second. That negative tells me that it's going down, so I'm not going to say that twice when I'm interpreting it. Let's say the next question asks us to figure out if the ball is speeding up or slowing down at that same time. Now, looking at velocity alone is not enough to determine whether or not it's speeding up or slowing down. In order to be able to tell this, we've got a couple of options. One, we could look at the velocity directly before 1 second and directly after. If that velocity is increasing or getting larger, then we know that it would be speeding up. If it was getting smaller, then we know that it's slowing down. But we can also look at how the velocity and the acceleration are working together or against each other. So again, we have the velocity function, the derivative of the original height function, which is 20 minus 32t. Now, knowing that acceleration is the rate of change of the rate of change, I can find that by taking the derivative of the velocity function. So the derivative of 20 is 0 because that's a constant, and the derivative of negative 32t would just be negative 32. So this problem, there's a constant acceleration, and my units would be feet per second squared. Now, this is something you are really familiar with. It makes sense that there's a constant acceleration on this, because the acceleration on the ball is due to gravity. And negative 32 feet per second squared is acceleration due to gravity. So what we now know, first, the velocity at 1 second is negative 12 feet per second. The acceleration is negative 32 feet per second squared. Now, these two are working together. The velocity is going down and acceleration is pulling it in the same direction it's moving. Therefore, since they're both negative and working together, the object is speeding up. If one were positive and one were negative, then they would be slowing down. Now let's say the question wants us to figure out when the ball reaches its maximum height and what the max height is. Now, if you think back to our original equation up here, what we have is a quadratic equation that's opening downwards. So hopefully you thought about that, and we know our graph looks something like this. Well, we want to know at what x value it reaches the maximum, and we want to know, sorry, I should call this t, we want to know at what height that happens. Now, when you're thinking about this, you're thinking about the ball going up and then coming back down. There's a split second when the ball is up in the air where it stops, because it stops going up and starts coming down. And that is going to happen when the velocity is equal to 0. So what we can do is we can take our velocity function, 20 minus 32t, and we can set it equal to 0. We can solve this to figure out what time it happens, and then we'll be able to plug that back into the original function to find the height. So solving for t, I'll add 32t to both sides to get 20 is equal to 32t. And dividing both sides by 32, I'll get t is equal to